Hey guys, I hope you can hear me finally. If yes, just like let me know in chat once. I am doing this for the first time, so please bear with me. We'll get better in streaming more because I have more plans to do more live streams. Just confirm in the chat window if you can hear me. There are a bunch of people who are still saying no, so I'm just waiting for a few seconds. All right, I think a lot of people can now hear me. So, everyone, the agenda for today is nothing special, but I'll be solving few problems on lead code using graphs. And if you have some time and you want to join me in, in solving some graph problems together, feel free to, stick around and let's solve few problems. So what I'll be doing is I'll be opening the problems one by one and start solving from easy. And it's quite astonishing that there is only one easy problem on graphs, right? Like I have sorted this on difficulty order. I didn't expect that there's only one easy problem, but let's do that first and then we'll move on to a couple of medium and then we have a lot of hard problems. So let's see how this one goes. If in any time you feel like if there is some lag or there is some, visual problem or audio problem, just let me know in the chat window. And I'll be pasting the links in the chat window as well as on the Discord server. So if you want to join that, feel free to join that as well. All right. So I'm going to just, simply post the link to join the Discord community if you want, just in case if you want to, chat over there. So I'm quickly pasting the link to Discord in the chat window. All right. So let's solve the first problem. We have find the town judge. Skip C++. All right. So this is the problem that we will be solving. I am posting that on the chat window as well as on the Discord. And let's see. So in our town, there are n people labeled from 1 to n. And just to make it more, hopefully now you can read it better. So there is a town, there are n people labeled 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Okay, everybody except for the town judge trusts the town judge. Okay, so the town judge is trusting nobody, and everyone else is trusting the town judge. And there is exactly one person that satisfies property 1 and 2. You are given trust, which is an array of pairs. Trust AB is representing that the person who is A trusts the person who is B. All right. So if this is 1, 2, the first person is trusting second person. All right. So of course, the second one is the town judge. And now what do we have to do is, of course, if the town judge exists and it can be identified, um, we have to return the label of the town judge. Otherwise, we have to return -1. So this sounds like an interesting problem. Let's see some examples as well. So 1, 2 is quite straightforward. If person 1 is trusting person 2, then of course person 2 is the town judge because there are only 2 people. And it can be the case that the input is really corrupted. So we have to return -1 also if you can't identify the town judge. So in 1, 3 and 2, 3, what's happening is everyone is trusting the third guy. So the third guy is the town judge. And similarly, if n is 3, 1, 3, 2, 3, 3, 1. So this means that the first person is trusting third, second is also trusting third. So it looks like the third person is the town judge, but the third person trusts first person, which violates the property for town judge because he can't trust anybody. All right. So this is quite easy, I think. As we have seen, right? Like if you iterate on pair A comma B, you can straightway eliminate A from the answer, right? Because if A is trusting somebody, A can't be the town judge. So what we can do is iterate on all these pairs and we can simply remove the first person from the possible town judge criteria. He can never be a town judge. Let me also put myself on do not disturb mode. What they're receiving. All right. So again, in this case, if we'll see this one, this is again same. The first person can't be trusted. Sorry, the first person can't be the town judge. Second also cannot be. The fourth cannot be. So we only have left with third one. And constraints are also very trivial. We have up to 1,000 people. The trust array is up to 10,000, and the length is always 2. The pairs are always different, which means that the first number in the pair is not as the second one. And since they are people IDs, they will always be in the range 1 to n, which makes sense. So hopefully, this is quite easy to solve. And I'll just go to the comment section and check with you guys if this is making sense. So the proposed algorithm is basically, I'm repeating again. We, if person I trusts person J, I can say that person I will never be a town judge. All right, that makes sense because uh, if person I is trusting somebody, person I can't be the town judge. It's given. So I'm keeping my choices as like I'm maintaining a set which is having all the person as valid choices in the starting, and one by one, when I get the information that person I is trusting somebody, I will remove person I from that set. That you can't be the town judge. At the end, if I have something with me, I can say that these are one possible. Basically, that guy can be the town judge. All right. So let me zoom in on the screen, make the font size a bit bigger. All right. So find judge, we have n people for auto edge and trust. So the first guy in that is edge dot first. Second guy is edge dot second. Okay, so it's a vector. So let's do it this way. So person U trusts V. Initially, let's say possible or candidate. So initially, we are having a candidate array. Let's have it n+1 for one-based indexing. So one-based indexing candidate, since U is trusting somebody, I'm saying that candidate U is false, right? And then we can say for int I is 1, I is less than equal to n, I plus plus, vector int final candidates. So what you can say is if candidate I is still 1, it means it's still no one was this guy was not trusting anybody. So we can say final candidates dot push underscore back I. So hopefully this is making sense so far. Let's see what else. So now it can happen that there are multiple candidates. So you have to check if final candidates dot size is not equal to 1. You have to return -1. And if it's 1, you can simply return final candidates 0. So far this is making sense, right? Let's try to run the code. So for this one, it's working fine. Let's try to submit. Should we submit? Now this is one thing, like, are we sure that this is like going to cover all cases? This is one thing that you should definitely think. Like, treat this submit button as if like you are saying that the viewer, I am pretty much sure that this solution is going to work in all cases. So one edge case that you want to test over here is what if this is empty? So if this is empty, is your solution crashing somewhere? It doesn't look like that. We are always, basically everything is looking safe, so it won't crash. But if it's empty, what's going to happen? This is not going to run. This is, again, basically Yeah, this looks like this is going to cover a lot of cases. So let's try to submit this. So we are getting wrong answer for 1, 2, and 2, 3. What is it? So the first guy trusts second guy trusts third guy. Output expected is -1. And the reason for that is, so we need more conditions, right? This is not enough that you eliminated 1 and 2, so you are saying that third is the town judge. That's not the case. So what's happening is basically the first person is trusting the second guy, and then second guy is trusting third guy. So what's going on over here? Let me just understand that. So the first person is trusting the second person, and I'm hoping that all of you are also writing your own code. So it's good if you also open your laptops and start solving together. So let me just go to the problem as well once again. Is it the case that the first person should also trust the third person, something like that? Yeah, so everybody trusts the town judge. What we are ensuring is town judge is not trusting anybody. This is what we have ensured, and um, everybody trusts the town judge. So this is something which was not happening in our case, I think. Where is the summation? Yeah. So in this case, the first guy should also trust the third guy, which is not happening. So what we should actually do is basically we can say we can store for a given person how many people are trusting him, right? And if everyone is trusting, yeah, basically we can do something like that. So instead of maintaining a candidate array, what I'm saying is let's process the edge in the fashion that, if person U trusts person B, we basically enhance the counter of person V, like we increment the counter that V is being trusted by one person. So let's change our solution to that. So basically, instead of candidate, we are saying um, number or count of being trusted, or you can say followers. Let's call it like that. So you can say followers of V plus plus, right? And then what you can say is if somebody has followers size as n-1, so this means that everyone is trusting this guy. So this is a final candidate for us, and we push that to the vector. And now again, we can do the same check. So now what you are doing is basically storing like how many people are following somebody. And if some person has n-1 followers, so this time we are also guaranteeing that everybody trusts the town judge, right? So that's something and we also have to make sure that town judge trusts nobody. That is something which we have missed over here, right? So we can have another array as well, like does follow n+1 0. So does follow u can be marked as 1. So does follow array is giving us whether some person is he following somebody or not, right? So if followers I is n-1 and does follow I is 0. So basically, this guy does not trust anybody, does not follow anybody, does not trust anybody. So this condition is ensured. And followers I is n-1, meaning everybody is trusting that. So that's a final candidate for us. All right. So now we have does follow n+1 0. This looks again good. And now let's try to sum it. All right. So it's been a while. Sorry about that. I should have caught this, and I'm doubting like these awkward situations might come again and again. But yeah, let's see. All right, let's move to some second problem. If anyway you had to go to the solution once again, you can have a look over here. I'm going. You can pause the screen and have a look at the code. It's quite straightforward. Do people have any comments on this? Everyone should trust the judge. So just have a look at this. I'm meanwhile going through the comments and and I will answer a few questions if you have. So Tarsh is asking, can't we use map? So basically, we are using vectors over here, and the question somebody has asked is, can't we use something like this for followers and does follow? The thing is, you can, but if you do that, the lookup in this is order login. Whereas if you do a lookup over here, like you are doing this followers v plus plus, this is order one, versus in maps, it will be order login. If you do use unordered maps, which is based on hashing, it can again go to order one. So you can do that, but again, like for such a small n value, I think it's better to use vector of int. So I hope that makes sense. All right. What else do you have questions? Oh, so someone donated us 100 rupees. Thanks. Um, so the question is, I'm sorry to disturb. This might be off topic. Can a BCA student with good skills in CP get referral for product-based companies? Can a BCA student with good skills in CP get referral for? Of course you can. I mean, if you are having a good CP profile, if you are already doing good in competitive programming, you have good rating on Codeforces and CodeChef, you should definitely try to network with other people on LinkedIn, and also basically have like basically you might be having your friends, right? So it's like really simple. Like when you're talking about friends and all those things, just simply approach someone, and when basically someone is referring you, they are also having the benefit, because if you get hired, they do get compensation for that. They do get bonuses depending on company to company. So it's very easy, and I think a nice way. If you have basically your resume ready, just simply share your drive link with people on LinkedIn. And I do have videos explaining how to do that. Simply, basically go for some company, try to find 5 or 10 people working there, and just send them messages over there. All right. Um, I'll be again, guys. Let me just fix the lighting over here. I think there is a bit of darkness. I'll fix that. Okay. Any more questions? CSC password, mad respect. Thanks. A single vector maintaining difference between in degree and out degree also works. Yeah, exactly. That's exactly what we are doing. So Swarnava Das is saying that basically followers and does follow. What they are essentially doing is counting the in degree and out degree. So that is exactly what we are doing. Yeah. All right, guys. I think let's move on to one more problem. Everyone has solved this, and I have given enough time to go through the code as well. I hope this makes sense. The problem link was already, in the chat window as well as Discord. So you can, again, the second problem link will also be pasted there. So the second problem is find the center of star graph. And again, this is having like really weird like and dislike ratio. So probably I will just open the second problem as well. Which is having pretty good number of likes and dislikes. So let's solve this. I'm closing this problem. Just because I have a lot of good problems, it seems like we have a lot of medium problems, and this one, I don't have the time to, judge whether this is good problem or not. So I'm simply going to close this and work on this one, right? So let's see. So we are given a directed cyclic graph of n nodes labeled from 0 to n minus 1. We have to find all possible paths from the node 0 to node n minus 1 and return them in any order. All right. So the graph is given as graph I is the list of all nodes that you can visit from node I. So basically we are given an adjacency list, wherein the ith list is giving us all the nodes that you can visit from the ith node. Okay. So that is what we call adjacency list. And we have a directed edge from node I to grow. Yeah, exactly. It's explaining that. All right. So this is the graph, and the output is 0, 1, 3, 0, 2, 3. And again, what do we have to return? All possible paths from 0 to node n minus 1. All right. So in this case, all paths from 0 to 4. Okay, so what do we have? We have 0, 4, which is direct over here. We have 0, 3, 4. We have 0, 1, 3, 4, 0, 1, 2, 3, 4, and 0, 1, and again, wow. So basically, there is no cycle, because otherwise there will be infinite such paths. So that's the first observation. If you had a cycle, you can go to that cycle one time, two time, three time, and you will always end up with more unique paths. So that's why I'm pretty much sure that we have a directed acyclic graph, so that we have finite answers, we have finite number of paths, and now the problem is to return that. So this looks like a crazy problem. What are the constraints? The constraints are really less. We have n up to 15, so it's really less. 2 to the power 15 is nothing but, let's see, 32,000. Okay. So up to 15 nodes in the graph, and the graph is guaranteed to be a DAG. All right. So let's think for a while and see how we are going to approach this. Um, so let's see. So this is interesting. What can I say? Can I say something like, we can get path, if I get path from 1 to 4 and then 3 to 4, right? Right. That might make sense. Okay. And 4 to 4. Okay. So basically what I'm saying is, I have to go from 0 to 4. And what I'm saying is, I will iterate on the children of 0. And I will say that if I can find all the paths from my child nodes to the ending node, I'll simply, I will simply append 0 in the front. So I will simply push 0 to the front of all those paths, and that will become valid paths from 0 to 4. So what I'm saying is, to get paths from 0 to 4, and I'm talking about this diagram on my left. So to get these paths, what I'm saying is, iterate on children of 0, right? So that's one thing. Find paths from child. Let's say we are iterating on child v of 0. So let find paths from child v to 4. All right. So that's something that you have to do. Find all the paths from child v to 4. And all those paths will become valid paths. Why? Because I will, if I had a path from, let's say, 1, 3, and 4, right? So this becomes a valid path for my original answer, because I will simply add 0 in the starting, and that becomes a valid answer, right? So this is what I'm trying to say. So find paths from child v to 4 and simply add 0 in front of them. And yeah, so this makes sense to me. Let's quickly, write this up. We'll figure out if it's if we need to use any dynamic programming kind of thing over here, but the constraints are pretty much like really trivial. So let's see. Let's have some, code in place. So all paths. What I'm thinking is, let's have something like, all right. I'm hoping you are also solving this side by side again, right? Um, just don't watch from mobile. I would suggest you to. So this was a evening where we solve problems together, right? I hope you are also solving this. Um, all right. So what I'm doing is essentially for um, so, so so I'm assuming that the number of nodes would be graph dot size, right? And then for int I equal to 0, I is less than n, I plus plus. What I want to do now is basically for int v in graph of I. This means that there is a pair. So I'm going to insert the edge gi dot push underscore back v. All right. So I'm just passing the graph, converting into something that makes more sense to my code. So I'm just converting the graph till now. Um, and what do I want to do is basically get all paths. So get all paths from source to, so target is same, but let's keep it anyway. And this is going to return vector of int. All right. So this is what we are going to do. And let me just, fix the brightness of my camera. Just give me a second. How do I do that? I go and increase the brightness. Hopefully that is better. All right. So I'm back, get all paths. And what we are going to do over here is return get all paths from 0 to n minus 1. So this is what we have to return, right? Let me just confirm again. All paths from 0 to n minus 1. So we have given the complete responsibility to this function now. It returns all the paths from this source to this target. And what I am essentially proposing is vector of int answer is, or paths is, initially it's empty. And I can iterate on children of my source vertex. And then what I'm saying is, so let's call actually vector int as path and make our lives a bit more easy. So I can say using path as vector of int, we have to return a vector of path, right? So this becomes more soothing to eyes, I would say. Yeah, so for int child in my source vertex, I can find all the paths from that to the target, and that will be giving vector of path, right? Let's call that remaining path. And basically what we can do is insert to the basically beginning of that. Do we have something to insert in the beginning of vector? Let me just quickly check that once. Vector insert in beginning. We can use DQ if we want. Um, that makes more sense. I'm pretty much sure that in vector, if you have to insert in beginning, that will take a lot of time. Exactly. So this will take a lot of time because you'll have to shift elements. So it's better to use DQ in our case. But or can I do it reverse? Yeah, so basically I right now so basically I'm doing a dirty hack right now. What I'm going to do is I'm going to assume that this always gives me paths in reverse order, and then before when I want to return, I can simply reverse all paths. If that made any sense to you guys. So I'll quickly say I'll quickly print and tell you what I'm saying. So let's move forward. So basically we have remaining path, right? uh, Vector of path remaining paths. So this is plural. And now what we can do is basically, and let me just zoom out a bit. So for path P and remaining paths, what I'm saying is my answer, let's call this answer. So I'm going to answer dot push underscore back P. But before I do that, I'm going to modify P. What I'm going to do is P dot push underscore back my current node, which is source. So all these remaining paths were starting from V and they were going to target. And I'm assuming that I'll be receiving that in reverse order. So essentially I'll be receiving from target up to V and I'm pushing back source to that and inserting that to answer. And at the end, I return my answer. So this is what I'm proposing to do. One corner case over here would be that if source is target, then return an empty vector because we are already there, right? So I'm not going to submit this. I'm just going to call and show you what's happening over here. Instead of returning, what I'm saying is vector of path is get all paths. This is my answer. I'm going to return answer, but before I do that, let me just, print this out once. This will be in reverse order. Actually, let's run it. The output will already say it's wrong, but it will show our output. Okay. So our output is currently empty. Let's see, we'll figure that out. But essentially what we were having is, I think this example corresponds to, we do not have a photo over here, but we have the first 0th node is um, basically 1 to 2. Then the first node is 3, 3, and then empty. So we have 0, 1, 3, and then we have 0, 2, 3. Okay. Um, so let's actually print down what's happening over here. So we go to 0, 1, 3, 2, 3. So what is this graph? How does this look like? Let's actually figure that out first. So we have the case of, let's quickly do that. So how does this graph look like? So we have 0 is having edge to 1, and it's also having edge to 2, right? So let's call this 2. Then the first node is having direct edge to 3, so something like that. And what else do we have? The second node is having edge to 3, right? So that will become something like this. Okay, something like this. All right. So 0 was having edge to 1 and 2, and then 1 is having edge to 3, and then 2 is also having edge to 3. So we have 0, 1, 3 as one answer, right? Then we have 0, 2, 3, right? How do I look my console? Yeah. So 0, 1, 3 and 0 to 3 is one answer. What happened in our case? Let's see. So we do have 0, 1, 3. We do have 0, 2, 3. So we did reach out. Um, Over here, we did come over here. Let's see what's happening. So vector path answer is over here. For v in our this, we from 0 we went to 1, we went to 3. So 3 was the target node, right? And -1 is the target, right? Why I'm running it again? I just want to look again. Yeah. So 0, 1, 2, 3. It should have worked, right? We are returning empty over here. Answer is empty. For int v of source, I'm finding my paths from v to target, and I'm appending source to all of them. I'm pushing my p to answer, and I'm returning my answer. And this is empty right now. So let's add more debugging over here. So what would have happened? From 0 we went to 1, right? From 1 to target. Let's actually, so when we went to 3, we returned an empty array. And okay, so since it was basically I returned this as wrong, so this should be something like this. So this is valid thing, right? So this is the problem over here. What was happening essentially was that we returned, when we were at the end node, we returned an empty path, which was basically null set in essentially this. So there is a problem. There's a difference in this and this. So when we returned this, what was happening? This for loop was not functioning, and that's why answer was empty. But now what we are saying is we want to return an empty path. So this is an empty path. This is the difference, right? So now I will just run the code, and I expect that this will be in reverse order. Okay. So 1, 0, 2, 0. Yeah, of course, I should append 3 also over there. So 3, 1, 0 and 3, 2, 0. So that's exactly what I was saying. We will get in reverse order, and I will then again, do a reverse before returning. All right. I'm not changing to DQ because we essentially have to return vector to vector end. So we anyway have to do this conversions. So it's better to use like this only. We will do the reverse at the end. All right. So over here we can simply return the target as like this, and this should work now. I'll have to do the reversal first. Yeah, so we are getting in 310 and 320. So if we now do a reversal, our answer will work. So how do we do that? You can say for auto ampersand p in path, right? So over here, I'm using ampersand, which means we are iterating on a list using reference. So if you make any changes to this, the original list will also be affected. All right. So how do you reverse? We already have STL for that, right? Reverse vector. All right. So reverse p dot begin, p dot end. I'm expecting that this will change the list itself. Yeah, I hope so. Let's see. And the reason why I'm a bit out of touch is, let me see, an expected type name path. Okay, so this is answer. So the reason why I had to look up is also because, I have been working in C++, JavaScript, and Python. So it does take me, like, I often get confused between the syntax of different languages. So yeah, I have to do some kind of, Googling some here and now, everything. All right, so this looks cool. And before I hit the submit button, I want to make sure everything is looking fine. If the graph is empty, n will be 0. This won't function. What will happen over here? N is 0. So here is one thing. So if the graph is really empty, what's going to happen is, so can graph be empty first of all? I don't think so. There will be no self loops, but I don't think the graph is anyways going to be empty. But even if it is, we should return an empty list. Are we covering that? Let's see. If so, we should actually handle it, not to basically call the wrong things. Basically, calling get all paths with 0 and -1 does not make sense to me. So if n is 0, it's not fine. We should simply return something like this, or this actually. So now it looks fine. We are covering a case. I'm not sure if it was well covered in the test cases, but let's see. Are we going to get time limit? I'm not sure if we need to use something over here. So we are using, we are getting wrong answer over here. So expected is, so we are doing a bunch of C out over there. That's not needed, but our answer is over here. And the problem over here is, I think about, let's see. So we have 0, 4, 0, 3, 4, 0, 1, 3, 4, 0, 1, 2, 3, 4, 0, 1, 4. Okay. There were no, so let's see what's happening over here. So 0 is having edge 2, 4, 3, and 1. Okay. 0 is having edge 2, 4, 3, and 1. And then we have the first node, which is having edge 2, 3, 2, and 4. All right. So the first node is having edge 2, 3, 2, and 4. So something like this. It's actually directed, so it's quite difficult for me to use it over here. I would need pen and paper to process this faster. But let's see what's happening over here. Let me figure out from the output. So 0, 1, 4 is there, 0, 1, 2, 3, 4. So we do have duplicates in our code. I think that's the problem. And that's why we are getting wrong answer. It should be a set. So if we make that a set, it will work. So we are not handling duplicates. If we are having that, we are having a lot of them, right? So basically, if we use a set, then it will work. So what I'm saying is, instead of getting this, we get a set from this, and no need of doing the C out. We are getting a set and paths. And when we are returning at that time, we are going to convert that into a vector. So basically, I am using paths, and this will become insert. And this will again become, let's see, set of path. So set of paths, and then I think this can work. So it seems to me like we are having duplicates over here, which is not fine. Again, this will be set, or we can simply use auto. So this is one thing that we should leverage. C++ will automatically figure out what is the return type, right? Okay, what else do we have? Okay, so we can't do reverse on something like that. Uh, okay. How do I reverse? What is the problem over here? I'm not sure. Okay, I think we can't iterate something like this. Is that the problem? Okay. Yeah. So I think set is having right. Okay. So set is basically ordered, right? So since set is ordered and I'm iterating on reference on the value, I cannot make any change to that because of that we can't use ampersand over here. Okay, so that was the problem that we were having. But in any case, we don't need that because we are anyway now returning answer which is different from this path. So it's okay to iterate by a copy and reverse and then push that. All right. What about memorization? Do we need that over here? Okay, so what is the problem over here now? We have 0, 1, 3, 4, 0, 2, 3, 4. So we are having an extra. So this is fascinating, right? We are having one extra entry. So some case that we have missed. Yeah, this is weird. So this should never happen because um, we are not having any path from 0 to 2. So 0, 2, 3, 4, it's not possible because from 0 the only edges are going to 0, 1, 0, 3, and 0, 4. So there is definitely a bug. We do not have 0 edge from 0 to 2. So how is that happening first of all? Let's see. So 0 to 2 is not having any edge. This is really confusing. How can this be inserted, right? Because for this to happen, there should be a path from 0 to 2. There is no edge from 0 to 2. So this is why we are getting a wrong answer. And is there any, yeah. So this shouldn't happen. So let's actually investigate what's happening. 0 to 4, 0, 1, 4, everything is correct otherwise. So let's see, let's go through the code once we'll figure this out. We are having graph size, we are building this graph. I think if this graph is correct, let's actually quickly validate if this is functioning fine. So for int I equal to 0, I is less than n, I plus plus. I'm just doing a quick validation on whether I have built the graph correctly. For int v in g of I. Oh, okay. I think we should do yeah. Yeah, I think I can see the problem. I think we should do a cleanup of our graph because there was no path from 0 to 2. It might happen that the lead code is, calling our function again and again. And we are not resetting the graph. Maybe that's why this issue is happening. So we should do g of I.clear, right? And I could have, easily figured that out if I was printing this anyway, I could have seen. So what I'm saying is, let's actually do it as well. Yeah. Let's comment this. Let's first try this out. So what I'm saying is, I should always clear my graph um, before I start building things because 0, 2, 3, 4 cannot be given from my answer. Yeah, so it might happen that there are residual edges from the previous run, and because of that, I'm getting wrong answers. So this is something which I expect should solve a problem. Let's see. All right, so this is success. Okay, cool. So I think the problem was pretty good actually. If I could solve it in the first go, it was really good. But the okay, so let me walk through what's happening over here. So to get all paths from the source to target, I have given that responsibility to get all paths. I'm passing in the source and I'm passing in the target. And if this function is doing its job correctly, I can simply, call get all paths 0 to n minus 1. I will get the set. I will convert that into a path, vector of path, and I will return that. And path is nothing but vector of int. Just to make syntax a bit more easy, I'm using it. And this is not needed. And just to make life a bit easy, I'm assuming that I'm getting paths in reverse order. And that's why once I get the paths, I'm reversing them and I'm finally returning the answer. Let's let's understand what's happening in get all paths. In get all paths, if the source is target, we are already here, so we return this. Otherwise, I iterate on my children and I say that I want to get all paths from V to target, and that are my remaining paths. And all those paths I can append source to that path, and it becomes a valid path from this source to target. So we are using recursion over here, or you can say DFS, whatever you want to call. It's pretty much the same, and that's how it's functioning. We did make mistakes, and that's something we have to avoid, and that's why we should even so basically I know these concepts, but I'm out of practice, and that's the reason why I'm making such mistakes. So this is also one of the reasons I wanted to get back into practice, that I am also doing this live streaming kind of thing. This happens, but we were able to make progress pretty quickly whenever we were stuck, so that's the good thing. But yeah, let's quickly solve one more problem, and before I do that, let me address the questions in the comment section. All right, what do we have? Let's see. First of all, I am so sorry. I think I forgot to paste the link in the description. So I'm pretty much sure you guys have already seen the screen and pasted, but here is the problem link. I will also paste it on Discord. All right. So we have pasted the problem link. What else? What are people asking? Someone is asking, is Java still relevant? Yes, Java is still relevant. It's being used quite a lot in the industry. So if you already have some context in Java and you want to, pursue that, please feel free and go ahead. Java is a good language. There is no problem if you are talking in terms of career. What are the other questions? How does it ensure that? So this is old one. Let's move on to the questions for this one. Someone is saying backtracking. I mean, you can call it backtracking. I prefer to see this as a recursive problem because, to get all paths from source to target, I'm getting all paths from my child nodes to target. So yeah, backtracking, maybe you can say it like that, but I see it as a DFS and recursive problem. What else? Um, Someone is saying you can also pop underscore back in vector. Okay, yeah, I know we can do pop underscore back in vector, but um, we don't need that here. Thanks for telling, anyways. Um, any more questions? Someone is asking 3-year gap before BTech. Should I prepare for product-based companies? If you could be more elaborate, if you could elaborate on the question. Mac is asking that 3-year gap before BTech. Okay, so you were having 3 years of gap before BTech. Okay, no problem. Should I prepare for? Yeah, there is no relation between what was your past. If you want to prepare for product-based companies, you should definitely prepare. There's no problem. Um, anything else? Someone is asking, can we optimize it? Of course, we are using set of paths. That's something that we can look into. But I mean, the n is already pretty small, and that's because there can be a lot of possibilities. What else? Your Discord link, please. Okay, so Discord link. I think I have pasted it. I am pasting it again, but you can find that from my LinkedIn as well. But I am going to paste it again. So Discord is here. All right. Someone is asking, can you explain the time complexity of this? Sure. Let's see what's happening. So time complexity is pretty good, right? So let's see it step by step. What's the time complexity? So this is order one, order n. Building the graph, it depends on the number of edges that we have. So order n plus m, where n is number of nodes, m is number of edges. So this becomes order n plus m so far. And then we are calling this get all paths function, right? And then we are iterating on this. So the time complexity of this will be same as the number of paths into the average length of each path, right? So the time complexity of this is this for loop that we have over here, order of number of paths multiplied by average size of path, right? That's how I would say. Um, and the time complexity of this get all paths. Let's see what's happening over here. We are iterating on our child nodes. We are calling get all paths for that. Then again, we are iterating on those paths and creating the list. So essentially, it's order n plus m when you are um, where n and m is the number of nodes and m is the number of edges, because it's a common normal DFS problem, right? Um, so one thing over here is, and why we were having duplicates is also very easy, right? We could use memoization actually. That does make sense. So basically, what I'm saying is, if you are having a graph something like this, so we haven't used memoization. So because of that, we are doing repetitive work again and again. But let's say we have something like this. One is having edge to three, um, and four over. Let's use two over here. And let's say 3 and 2 both are connected to 4. Okay. So let's say the graph is something like this. One is having edge to 2 and 3. Both of them are having edge to 4. And then again, 4 is having its own subtree. So that's another thing. But let's say we have something like we have 100 nodes, and finally down the lane, we have 100 over here. Okay. So let's say we have a graph like this. There are directed edges. So from 1 to 3, 1 to 2, then 2 to 4, 3 to 4, and so on. And here is 100. So when you're going to find paths from 1 to 100, you are going to go to 3. You are going to find paths from 3 to 100. For that, you are going to go from 3 to 4, and you are going to find paths from 4 to 100. Similarly, once you have done this problem on the left side, which is for 3, then you are going to go to the next child, which is 2, and then for finding children from 2 to 100, you could have ideally, saved some time and memory, because you could have 4 to 100 over here. So you could have saved this computation again and again if you were using memoization. But since the constraints were so small, it's fine. I'm not using it, but this does call for memoization over here. That's what I want to say. All right. So again, this is a DFS, simple DFS order n plus m, but we are again iterating on the paths. So this can be quite a lot. At max, you can have something like n paths, right? I think so. You can have, no, but you can have different permutations as well. So again, it depends on the number of paths. It really depends on what the graph looks like. So this would involve more math over here, but otherwise it's an order n plus m traversal. But again, that has to be factored into or multiplied by the number of paths that we have and the average length of that. But over here, we are pushing that to the end. So that is order one. But the number of paths is something that you have to factor in, which might need more math for us to figure out the time complexity. All right. Yeah, so I think this is what the time complexity would look like. Cool, guys. I'll give you a 2-3 minute break. I'll also drink water and then we'll come back. Um, I'm just going to put break time. So let's be back in like 2 or 3 minutes or 5 minutes. Let's take a 5 minute break. I'll also drink water and let's solve one more problem, and then we can meet tomorrow or at late at night. All right, guys. Hey guys, I'm back. Um, let's move on to more problems. Do we have any questions? Let's see. All right. So do we have any questions? Um, Someone is asking, suggest data structures and algorithm course using C++. Yeah, we do have my code school, which is really good. You can check out their playlist. It's really awesome. That's definitely a good thing that you can watch for C++ especially. I have a like real good respect for that because um, the person who was behind my code school, basically, he was like the Lord Harsha, like really phenomenal Indian coder. He was read on top coder as well. So I remember the co-founder is in Google. He's in US. I have tried to contact him a lot of times because I have been really, I was really impressed by the work that my code school has done. But yeah, let's see sometime or like in the future, I do plan to, talk to the guy who is still basically who was the other partner behind my code school. All right. Any more questions? By deleting vectors or sets created in code, do we really clear memory? I don't understand the question completely, but what is essentially happening is even if you are allocating space, since this is a function, when this function goes out of scope, all the memory that was allocated for local variables, that's destroyed. So yeah, we don't have any leakage over here. Leakage generally happens when you're using pointers and you are allocating memory on the heap section using new or malloc, and then you forget to, clear out the memory using free or delete, something like that. Those are the keywords for freeing up memory. But we are not dealing with pointers over here, so we really do not have to worry about memory. What else? My code school is free, it's not paid. So yeah, you can check out their YouTube playlist. Really good for beginners. So let's move on to some other problem, guys. Let's solve some hard problem probably. Um, the way we are solving problems, it's not looking good, but let's see if we can solve a hard problem today as well. All right, so this looks like a good problem. We have good likes. The like ratio is pretty good. The problem is short. So yeah, let's actually solve this problem and call it a day, right? So let's see. So there are n couples, two n seats arranged in a row. They want to hold hands. All right. Very interesting problem statement. We want to know the minimum number of swaps so that every couple is sitting side by side. And let me put my phone on silent. All right. A swap consists of choosing any two people. Then they stand up and switch seats. Okay. And we want the minimum number of swaps so that every couple is sitting side by side. Makes sense. So what is the function signature? Let's see. Minimum swaps couple, we have vector int row. All right. Uh, what are the couples? The couples are numbered in order. All right. So the first couple being 0, 1, then 2, 3, and so on. All right. So that's how we have. The couple's initial seating is given by row I, being the value of the person who is initially sitting in the ith seat. Okay. So we have a seating arrangement like 0, 2, 1, 3. If you swap 2 and 1, it becomes 0, 1, 2, 3. And then everyone is happy. They are holding hands. Like, like who creates such problem statements, man? All right. What else? 3, 2, 0, 1. So let's see over here. Oh, okay. So they are already holding hands because 0 and 1 and 2 and 3. Yeah, so this looks like an interesting problem. I'm not sure if I would be able to solve this, but yeah, let's see. Let's see what happens. We will otherwise go to this discuss tab or something like that. But let's try not to go over there and figure this out on our own. All right. So the problem link, first I'm going to paste in the description. Problem link. I'm going to Discord as well to do the same. Third problem. All right. All right, guys. Let's do this. So basically, first thing is we do not want to make 0, 1, 2, 3. That's stupid. As we are saying in this case, right? We don't have to do any swap over here. 3 and 2 are happy, 0 and 1 are happy. This is really interesting. And we have the length is even, and in the range of course, it's even because we have couples. And in the range of 4 to 60, so it's not that big. Okay, no problem. Let's see, guys. Okay. Um, Minimum swaps needed. All right. How can we do this? And and the interesting thing is, like, you know, even the order is not important. It's just that the I and I plus one values should be together, right? And they can be in any place, as we are seeing. 0 1 need not come in starting. It can be at any place. Let's see, guys. Let's see. I hope you're also solving this together. Um, how to process this? Like, okay, so we have a lot of couples and they want to sit together. Um, so let's actually take an example and make progress, right? So, so let's see. So we have something like 0, 1, 2, 3. So that's fine. But if we have 0, 3, and then we have 1, 2. So we need a swap. And let's say 4 and 5 is also here. So over here, these are happy. 0, 1, and 2, 3 are not happy. So we have to fix that. And we can do swaps. All right. This is a good problem. Let's see. So 0 and 3, 1 and 2. Okay, so 0 has to sit with 1. So how can I make 0 happy? Either 1 can come close to 0 or 0 can go to 1, all right? And so if 0 has to go close to 1, either of the adjacent ones can go and take that place, right? So either 0 can be swapped with 2 or with 3. Okay, so let's say we have something over here. This guy is here, and then we have Z1. Then we have X plus 1 here, and then basically Z2 and so on. So basically, X and X plus 1 want to sit together, right? X and X plus 1 want to sit together. So X can be swapped with Z1 or Z2. Only, only then we can have something. How do we decide which one is better? X and X plus 1 want to sit together. Do you swap with Z1 or do you swap with Z2? So this is some other person, right? P1, P2, these are adjacent to X plus 1, all right? So I can make it like this as well. This is more accurate. So we have people sitting here, we have people sitting here, we have X in this position. And now X want to sit with X plus 1. So how can they sit together? So if you are swapping with P1, it will be P1 will be happy if we have P1 plus 1 over here, right? Something like that. Okay. Right. So this has to be so so the first pair will be here, then another pair will be here, and so on. So for X, all these pairs are already sorted. X is here. So this guy, if this guy is P1 plus 1, then we can swap with P1 because doing that swap makes P1 happy as well as X is also happy. So we have in one swap, we have fixed two couples. That's the best thing, right? But so basically I'm trying to process this, but I'm doubting whether this is going to get me somewhere. Do you, what are other people saying in the chat? Let's see. So someone is saying if I plus 1 are beside each other, proceed. Yeah, that's fine. So someone is saying that if I and I plus 1 are sitting, yeah, so that is true. If I and I plus 1 are sitting, like they are already sitting beside each other, we can leave that as it is. But again, like how do you process this, guys? What are the thoughts which are coming to your mind to approach this problem? All right, so someone is saying we can first find the couples which are unhappy. That makes sense. All right. Right. So basically, let's do one thing. From our graph, let's iterate on even positions in zero-based indexing, even positions. And if there is a pair which is happy, let's just remove it. So once we remove those pairs, we have a list of people sitting and everyone is unhappy, right? We have removed the couples who are happy. We do not have to disturb them, right? Because they are not doing anything. So in this case, 0, 3, 1, 2, 4, 5. So let's iterate on even indices. So 0, 3, not happy. 1, 2, not happy because 1 has to be paired with 0, not 2. 2 has to be paired with 3. So this is not happy. 4 and 5, they are happy. Even if this was 5, 4, they were still happy. But since they are happy, I'm going to remove them, right? So this is the first step. So now we have a uh, list of people. Like we have a seating arrangement where everyone is unhappy, and of course we need to do swaps now to make them happy. So to fix one couple, we can. So one couple can always be fixed in one swap, right? So if we can do n swaps, n by 2 swaps actually, that is the like the trivial solution is n by 2 swaps, but we might be able to do better, right? Because when you do one swap, you are making two people happy, and if you do right, that's what I'm saying. So in one swap, you can fix one couple. There are n couples, so yeah, n swaps can be the answer. So in this case, and now the optimization is basically if you can make a swap which is making two couples happy, right? That is something which basically which is the best scenario, right? In this case, if you swap 1 and 3, this will become 0, 1 and 3, 2, which makes everyone happy. So basically, this is what we can do. One swap can make two couples happy. This is like the first priority, right? Find a swap that can make two couples happy, and keep on doing that. And finally, if you can't do that, then we'll be doing swaps to make people happy. And do we need more swaps? Like, do we need to do swaps in which um, two couples are not being happy? Can there be a scenario? So let's see. So we have 0, 3. Let's have 5 here, 2 here, 1 here, 4 here. All right. So what can we do over here? So no one is happy. Of course, no one is happy. What can we do? Let's see. If you swap 3 and 1, right? That's a good scenario because 3 and 4 will also be together. So that's really good. No, 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 no. 0, 1, 2, 3, and 4, 5, right? So 0, 1. So 3 has to pair with 2 actually, right? Yeah, yeah, yeah. So actually, answer is 2 over here. You can swap 0 with 2. So that will become 2, 3, 5, 0, 1, 4, right? Okay. Oh, okay. I think I am getting closer to the solution. So basically, over here there has to be one couple. So either it would be 0, 1. If not that, it would be 2, 3. 0, 1, 2, 3. Yeah, yeah. So you have two choices only. Okay, okay, okay. This makes sense. So for the first unhappy couple, either one is going to come here or two is going to come here, right? So basically, if you swap 3 with 1, you get swap 3 and 1, you get 0, 1, 5, 2, 3, 4, or you swap um, 0 and 2, right? And you get 2, 3, 5, 2, 1, 4. So in this one, 0, 1 is a happy couple. Um, this is not happy, this is not happy, this is also not happy, this is also not happy, right? Anyone, any idea? So basically, in this case, it doesn't matter, um, because 2 is still not with 3. Uh, yeah, would you say this as happy? No, I don't think so, because all the couples will be at even indices, right? Yeah. So 5 has to sit, right? 0, 1, 2, 3, and so on, right? So in this case, it might sound that 2 and 3 are happy, but it's not going to solve our problem. Why? Because a couple should always be formed at even indices. Okay. In this case, the indice of 2 is 3, which is odd. And since there can be no couple at odd indices, because it means that there is someone who is not sitting with their partner. In this case, 5 and 4 are not sitting together, right? So it might sound that 2 and 3 are happy, but it doesn't matter, because in any case, you have people who are not happy. So, okay, so 2, 3 is fine. Over here, now you can do one swap and the problem is solved. You can swap 1 and 5 over here. So basically, you swap 1 and 5, you get 2, 3, 1, 2, 5, 4. So in two swaps, you are able to solve this problem. Over here also, you could swap 5 and 3. So you will get 5 and 3 swap becomes 3, 2, 5 and 4. I made a mistake over here, I guess. So when I'm swapping 0 and 2, this becomes 2, 3, 5, 0, 1, 4, right? Yeah. All right. And over here, you swap 2, 3. You can swap anything. 5 and 1 or 0 and 4 doesn't really matter. So let's say you swap 5 and 1. This becomes 1, 0, 5, 4. All right. So we needed two swaps, but again, I'm not sure why this is a graph problem and what are we missing. Let's think a bit more. It's kind of sounding something like bipartite. I'm not sure why, but let's see if we can do something. So 0, 1, 2, 3, 4, 5, 6, 7. All right. So let's think it like this, right? We have people on left side which are 0, 2, 4, 6, so and on. And then we have people on right hand side 0, 1, 3, 4 and 5, 6 and 7, right? So this is a pair, this is a pair, this is a pair, and we want them to sit together. So what happens if I make a graph? So basically I made a bipartite graph. Of the indices. Does that make sense? How can it help? How can I leverage graphs over here? Let's think in that direction. All right. So we have 0 over here. Okay, this might take a while. So if you want to solve this on your own, or if you want to take a hint, please feel free uh, and take that hint. I'm really taking my time, and if I'm not able to solve it in the next 5 or 10 minutes, that's the point when I'm going to get the first hint, because I'm lucky that it's not a real interview, because I'm really not, well versed with graphs right now. So yeah, and that's why we are doing this basically. So let's see. In this case, if I create indices over here, so 0 is at 0 position, 1 is at 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 4. All right. Hmm. Shall I create bipartite graph, or I should create a directed graph? I'm thinking like that. Let's do both and see what's happening. So the indice of 1 is 0, 1, 2, 3, 4. So the pair of that is at this. And then we have, where is 1? Where 1 is at, okay, 1 is in, 2 is at 3. And then 3 is at position 1. And then we have 4 at position 5. And then 5 is at position 2. I'm not sure if this is going to help, but let's see. And we don't have anything else, right? Six elements, okay. So this is basically indices. Okay. Um, right. Yeah. Yeah, all right. So basically, okay. This makes sense. This can work actually, right? So basically, what I want is basically this is four. These are indices. Okay, these are indices. Okay, so all the odd and even indices should be on this hand side, and all the odd indices should go over here, right? Yeah, that can actually make sense. That can actually make sense. So basically, what I'm saying is these are indices, right? And as we have discussed, all even indices should come over here, right? Yeah, that makes sense. Yeah. So basically, all odd indices should be together and all even indices should be together. I think something like that, if it's making sense. Yeah, and the difference should also be one. It's not adding up. So basically you can do swaps over here. You can do swaps over here, and at the end, what we want is basically, yeah, the difference between these two indices should not be more than one. All right. No, this is not making sense. Let's actually create a graph and see what's happening. Um, so zero is at zero position. Let's create a graph from 0 to 4, right? Why are we doing that? I'm not sure. I'm really blocked, man. I'm not having more ideas. Um, if I do that, no. So what I want is 0 to 1, 2 to 3, 4 to 5, 6 to 7. Yeah, so this is what we want. Basically, at every even index, we want a pair, right? It can be x plus 1, it can be x plus 1 x, but we want a pair. So in this case, what we have is position of 0, 1, 2, 3, 4, and 5, right? And we can do swaps. Okay, so if I do swap over here, okay. Mhm. Right, this is tough problem, man. Mm. I'm not able to make any progress. I'll have to look at a hint for this one. So let's see, man. Do we have hints over here? Say there are n two-seat couches. For each couple, draw an edge from the couch of one partner to the couch of other partner. Okay, so it's saying that there are n two seats. For each couple, draw an edge from the couch of one partner to the couch of other partner. So that's what I was doing, but how is it going to help me? I should have not stopped. Let's see. So these are indices only, right? 0 to 4, and 3 to 1, and it's actually unordered, and 5 to 2. Someone is saying in comments, take help from Gaurav. Someone is saying why coding is so hard. Uh, Someone is saying this problem is really hard. Hard. I have tried but not able to solve. Even sub submissions are on. Yeah, man. I think I had been doing programming for quite a long time. I have not solved this problem before. Of course, we can see that. I had been out of touch as well. but I generally was able to solve problems, but over here it might take me more time. And since I'm doing a live kind of thing, it's not okay to basically, waste a lot of time. So I have to move forward with hints if I'm not able to make progress. If had I been doing this offline, I could have taken more time. I could have used pen and paper. And this is my first live stream, so of course I am gaining more learnings. Next time I'll be ready with pen and paper as well, so that I can draw on screen and make more progress quickly with you guys. But overall, I hope the stream is working fine so long. I'll um, so yeah, coming back to the problem. So it's saying there are n two-seat couches for each couple. Draw an edge from the couch of one partner to the couch of other partner. So that's what we have done over here for this example. 0, 3, 5 to 1, 4. I have drawn the edges. What do I do now? Draw an edge from couch of one partner to the couch of other partner. That's fine, but it's not helping, right? Or can it? So what happens when you do a swap, right? Let's see what happens when you do a swap. When we did a swap of 3 and 1, right? This means that um, so we reached here, right? Swap 3 and 1. Array became this. Originally, we were having this, right? And the graph for this one was this. And what will be the graph for this one? So we performed this operation. We swapped 3 and 1. We came over here. And now the graph, how would that look? So now 0 is now pointing to 1. And then 2 and 3 are at position 0, 1, 2, 3, and 4. So 3 and 4 here. 0, 1, 2, 3, and then 4 and 5. So 4 and 5 are over here. Right. It's actually like this. Okay. So what did we do? As you can see, we did a swap of this and this. So this became 0, 1, 3, 4, and 5, 2. And then the next thing that we can do is, in this one is, and 4, 5. So 2, 3, and 4, 5. So we have to switch 5 and 3. Swap 5 and 3. And if this is confusing, basically this is the graph of indices, as it's saying, edge from couch of one partner to couch of other partner. So 0 and 1 are sorted. They are happy sitting together, holding hands. 5 and 3, if you swap that, what happens is basically 5, 0, 1, 2, 3, 4, 5. 5 was sitting at index 2. And this one is being swapped with 3. So this becomes swapped with this one. So 2, 4, and then 5, 3. Wait, let's see what's happening. 0, 1, 3, 2, 5, and 4, right? Okay. So this is 3, 4, and this one is 5, 4. So basically over here, this is functioning fine. Why? Because, um, all indices are having difference of 1. 3, 2, and 5, 4 is also fine. That's no problem. But the indices are having 1 and um, man, I'm not able to solve this one. I do want to solve this, guys. So I'll most probably taking a break and solve this and be back. But I'll use pen and paper. I don't want to, go ahead with the solution, but I will actually take a break and come back. So yeah, I'm going to take a break. You also try to solve this, guys. because this is not making sense for me. It's getting a bit confusing without trying to do it together on a screen. So let me just go and check my pen and paper, and let's see if we can solve this. I'm going to start the timer, and before I do that, let me see if anyone is having any comments. Someone is saying call Gaurav right now. Shall I? Should I call Gaurav right now? Someone is suggesting something. So Brandon is saying start with two couple pairs, 0352, and find optimal swaps. My voice and add another pair until end. Um, Something similar to min swap to sort array. Okay. Okay. So yeah, I'm going to, yeah, use pen and paper. Feel free to also do the same because this is really, interesting for me. I love solving problems, and this is something which is really, I want to solve this problem. So yeah, I'm going to take a break and I'll be back, guys. Had it been a real-time coding interview, I am already sure that I was not able to solve even the hint. I'm accepting that I am not able to make progress. I'm not able to process it just using screen. I need pen and paper. So yeah, let's see how this one goes. I'll be back soon. All right, guys, I am back. Um, so I do think I have something. I'm not sure if it's going to work. I'm still processing it, but I do think I have made some progress. Let me just come back to my screen. All right. Uh, so so this is how I'm thinking about this. So as you were saying, right? Find a swap that can make two couples happy, and so and on. So the idea is basically, um, so basically think how should I put this? So think about it in this perspective that doing these swaps uh, is really random, and we doing swaps in certain way can be more beneficial than others, and we have to find that grouping. For example, in this case, we were having a grouping of two. Basically, there were four elements, and doing swap with one, or you can say that there were two couples, and they were related, and they were basically having a group. So right now, it's a group of four people or two couples, and doing a swap is making them happy. Similarly, there can be swaps of multiple groups in the sense that here were four people involved in sitting in each other's place. Similarly, there can be six people involved or three couples involved sitting in each other's place. In so and so and on. So think about this like this: A and B, and then it can be A and B and C, and you have to do swaps to get the permutation that you want, if it's making any sense, right? So what I'm saying is basically think of all the persons sitting over here as a permutation of couples, basically, right? Because one and two and three and four, that really does not matter, right? They can sit in any position. So what I'm saying is you can convert this into couple IDs. So a person I is having a couple ID as I by 2, right? So the first couple is 0, 1, right? This is the first couple. 2, 3, this is the second couple. I'm going to remove everything. We don't need all this. So yeah, this is how I'm going to explain. This is the third couple, right? So what I'm saying is 4, 5, 5, 4 doesn't really matter. So let's simplify the array. How I'm talking about simplification, what I'm saying is let's give them IDs. So so 0 is, so the first couple is having ID, let's say C1, okay? So this is, or C0, because you can simply do division by 2. Couple ID is 0, okay? First of all, you can hear me on the stream, right? Let me just check. You guys can hear me, right? Just confirm once, because I don't want to, um, speak and speak and there is no one who is watching. Or are there any audio issues or video issues? Is everything visible? You can hear me? Just type in the chat window so that we can move forward. All right. All right. So you can hear me, right? All right. So what I'm saying is, let's simplify the array, because this is really overwhelming to process so much of information. And since couple IDs are more easy to solve, because you can basically, instead of 2 and 3, if the positions of 2 and 3 were swapped in the original position also, it was same, right? So there is no relevance of different of keeping different numbers for the same couple. The 2 and 3, they are completely interchangeable, so it's better to use a common term to denote both of them, right? So how you can do that, you can give them couple IDs, because both persons will have the same couple ID. You can simply do a division by 2. Integer division will make sure that they are having the same couple ID. So the couple ID of this will become 1, and 2 by 2 is 1, 3 by 2 is also 1 in integer division. The couple ID for this becomes 2, right? So your input, which was this, will become nothing but 0, 3 is 1, then we have 2, then we have 1, then we have 0, then we have 2, right? Now this is making more sense, right? It's easy for us to visualize. Okay, so and we always want to make this as 0, 0. basically 2 2 1 1, or you can make it as anything like 1 1 0 0 2 2, right? All couples are sitting together. So this is more easy to play with, right? This is adding more sense. This was such a great simplification, I believe, right? I hope this is making sense. You are with me so far? I'm just waiting for you to write in the comment section if this is making sense so far. All right. Okay. So now once we have this, uh, what we want to do is we want to do swaps such that we want to minimize the number of swaps, and at the same time we want to make these couples stay together. So so what I'm trying to say is, now you can see this thing, right? Like there can be group of multiple couples involved, and you can continue to swap them to make them stay together, right? If it's making sense, right? So let's say if there is this X and then couple Y and then couple Z. If you want to, if these are the people which are involved, what I'm trying to say is, you can fix their permutation by doing two swaps, right? If there was just two couples involved, X and Y, you can do one swap, all right? Is it making sense? Like in this one, there are three couples involved. In this case, if you will convert this into easy form, easy notation of couple IDs, so this will become 0, 1, and then 0, 1, right? So over here, since swapping 0 and 1 will easily fix, uh, basically there were two couples involved over here, but over here there are three couples involved. Basically, everyone sitting here and there, and you have to adjust positions for all of them together, right? That's what I'm trying to say. So it's going to be like a cyclic effect. So if you fix one couple, the other is still disturbed, but now the other two are can be solved by just one swap. So that's what I'm trying to say. So if there are two couples involved, it's one swap. If there are three couples involved, to fix that you need two swaps, and so on, right? I hope this is making sense, right? Over here, basically there were two couples involved. Fix Doing one swap can fix both of them, and you can do this 1 0, or you can do the last ones. That's fine. That's still fine. So once you have that, what I'm essentially planning to do is that, um, for this, the graph, you can make the graph basically, right? Let's do that. So for every like basically 0 and 1 are couple which are sitting together. Like there is one person from couple 0, and there is one person from couple 1. They are sitting together, so they are related basically. Then 2 and 1 are also related. So there is one person from couple 2 and one person from couple 1. They are also like matched. All right. And then we have 0 2. Okay. So 0 2 is also having an edge. Okay. So that's what I'm trying to say. Um, the couples are related to three couples are related to each other. Similarly, there can be four couples, five couples, six couples, which can be related to each other. So to fix a to fix a cluster of, let's say, seven couples, you have to perform six swaps. All right, and that's how you can move forward. To fix a cluster of three couples, you need two swaps. To fix a cluster of two couples, you need one swap. So to fix a cluster of n couples, or let's say C couples, you will need C minus one swaps. All right. So the idea is basically to, build a graph in the sense that, what are the different. So basically, we are making a graph of which is telling us that person from couple X and person from couple Y are sitting besides each other right now. And essentially, what we want to do is we want to do swaps in that graph such that the graph is really simplified, that 0 0 1 1 2 2. So every person from its own. So basically, every person from a couple are sitting besides each other. right? That's what we want to do. So we want to break this graph and do this. And how do we break this graph? By doing swaps. And to fix a couple of to fix a cluster of C couples, we can do C minus one swaps, all right? So basically what I'm saying is normalize the array, make that into basically make our life easy by giving them couple IDs. Once we do that, we build a graph of what are the um, couples which are related to each other. And then we figure out in that cluster what is the size of each cluster. And then for to fix each cluster, we can do the size of that cluster minus one swaps. And we do that for all the clusters. And in this way, we can basically make sure that every couple is sitting happily and they're holding hands. I hope this makes more sense, right? I'll proceed with the implementation. Just um, all right. So this was quite a lot of like I really love solving this problem first of all, but it did take me time, and I do need pen and paper. Okay, so let's see. Um, N is row dot size. Okay, so basically what I can do is for int x in row, let's convert that. We can say x slash equal to 2. All right, so I'm converting the row into clusters. And how do I do that? By integer division. So this is nothing but normalizing the seating arrangement in terms of couple IDs. And we can actually do it like x is equal to get couple ID for this current person. And this get couple ID can be something as trivial as int get couple ID int person. So the person couple ID is nothing but person by 2, right? So that's what I'm saying. I'm converting into more easy thing, and then I'm going to build a graph now. Okay, so let's do that. Of course, this graph is undirected, right? And so for int I equal to 0, I is less than row dot size I plus plus. Let's see. Let's actually store int n as row dot size. I is less than n, and I plus equal to 2, right? We can do something like this. And now we know that C1 is basically row I. So this is one couple, this is another couple, row I plus 1. Now if C1 is same as C2, just move on. Okay, nothing to do, they are sitting together. Actually, this should be by 2, right? There are n couples, so n is number of couples. I have converted the seating arrangement into couple IDs. Now I'm iterating on each even position, and I am basically checking if I have to associate um, any two persons together. So let's quickly do that now. So G of C1 dot insert C2, and then G of C2 dot insert C1. And what is the size? So const int n is nothing but 70, and then we have set of vector of set of int g. All right. All right, let's see what do we have to do now. We can do the normalization as well, like the init stuff, which is saying g of I dot clear. All right. Now we are building a graph. It's an undirected graph. Now we can do is we can do a DFS to figure out the size of each cluster. So we can do int answer is 0. So we are iterating on so we are iterating on couples, and if not visited is initially 0. If not visited I, basically answer plus equal to get cluster size of the current couple minus 1. These many swaps will fix that. and we return the answer. So we have to implement this function. We also have to declare this 𝗲_sted. So let's do that. Bool 𝗲_sted n, and then get cluster size and u, and then it can be a simple recursive function for int v in g of u. If not 𝗲_sted v, only then you can say something like answer plus equal to get cluster size of v, and the answer is 1. Right? What am I doing? We just need to get the cluster size, right? So let's cluster size is 0, and let's actually fill cluster size. Let's use a more meaningful name. Fill cluster size, and we are going to pass that by reference size. It doesn't return anything. So basically we fill the cluster size and then cluster size -1. All right, so how do we fill the cluster size? It's simply basically how many nodes you're visiting, right? That's it. So in a given DFS, how many nodes you visit, that will be the cluster size. You are passing that by reference. So it will, after this call is finished, you will get the cluster size, and you add. So basically these many couples were related and sitting in each other's position, right? They were having this cycle, and to fix that, you kind of did cluster size -1 swaps, and now they were sitting with each other. And we are doing this for all the couples, because we are having a for loop and we are iterating. If there is still a couple which is not visited, we are again trying to start a DFS kind of thing over here. This is simple DFS, right? Fill cluster size is simple DFS function. We are basically, if not visited children, we start doing DFS over there, and cluster size needs to be passed. All right, so this looks good to me. Let's try to run this code. All right. So what is it saying? It's saying, okay, so it cannot iterate like this, is it? Okay, I can use a vector. No problem over there, even if it has duplicates. So this will become push underscore back. Ah, damn it. My bad, guys. So this is, all right, let's see. Runtime error, that's a very healthy approach to solve problems. What was the test case? 0213. We are getting so let's see what's happening. Let's see. Um, let's actually print the graph. So this is generally I do when I'm programming. If you want to make progress, quickly do some debug statements to make progress real fast. Um, Actually, you don't need this. You can simply say cout adding edge in couple C1 and C2, right? So this will work. Let's see what's happening. Run code. So we added a edge from couple 0 to 1. That's good. But it should have printed twice, right? because 0213 becomes 0101, and then so this should have been printed twice. I think it is getting some error in this place itself, right? Because currently you are at index I. So we have something happening over here. So let's see what's happening. Um, we had modified the row. Let's see how the row looks like. See out X. So it should become 0101. That's what I'm assuming. So it's 0101. N is nothing but 2, right? So I is 0, I is less than 2, I plus equal to 2. Okay. Okay. So we are not processing it. So this should be equal to N, something like that, I think. 0, 1. Yeah. But anyways, if, okay, let's see what's happening here. If not visited, let's see how the DFS is also functioning at couple U. So this is DFS. Okay. So it's never ending. So what happened over here? Okay, damn it. Come on, man. What am I doing? This was really stupid mistake. Sorry. All right, so this seems to work. We do not need this print statement either. Let's remove that. All right, let's see. We are marking that we have visited the current couple. So we have visited, so we are incrementing the cluster size. I'm iterating on the remaining couples that are connected with me. If I have not yet visited them, I'm going to do a DFS on them. So yeah, looks good now. What's happening to lead code? I mean, seriously, this has stuck, guys, but I do feel this is the right solution. I'm not sure what you are, what do you think, guys? Right, this is also equal to n, right? No, I think that's fine. No, I think the last couple ID can be n minus one, I believe. If there are six couples, then 6 by 2 is 3. The last couple will be 2, right? So and yeah, that's fine, I think. Over here, I don't think we are, so this is not right. So this should be row dot size, right? I is less than row dot size. We are not processing otherwise we have to process the all the edges. So this was wrong, definitely, right? So let me copy the code. Someone is suggesting that refresh and Uh, Duplicate. Where is the duplicate tab? Yeah. So let me go through the code myself once, right? Only then we will submit. So we have to process all the rows edges. So there should be I plus equal to 2, and that's where there should be row dot size less than that. Uh, yeah, this seems to work now. Let's submit. All right. Damn it. I had the title like live graph algorithm workout until we solve hard problems. We have solved one hard problem, guys. This was really awesome. I actually did not expect, and I haven't used lead code that much like for graph. I had been doing competitive programming quite a lot, so I was, quite familiar with a lot of things, but it's been a while, and I feel that it's definitely good way to basically do your revision. I could have done this offline as well, but I thought that it's good to do things together. I hope you have also solved three problems with me, and I hope you have learned how to do DFS and basically how to move forward when you are stuck. We did use a hint, but it was not that helpful. For me, I was not able to make much progress by using that hint. That's fine. Sometimes it happens, but yeah, like I have solved this problem, and one takeaway for me is basically, this problem was involving basically cycles, and this kind of thing is something which I have encountered previously as well, and this is something which I'm taking forward. This learning is I'm taking forward with me, that if there are basically permutations kind of things and you have to make things right, try to so basically this problem involves cycles. Like it's not that doing one swap will fix two couples and you can end it over there. This swapping can go on up to for three couples, four couples, five couples, and so on. So you have to understand that such permutation problems, these swaps involve groups of different couples or groups of different. Basically, it's a cluster of different nodes, and you can do swap operations of like if the cluster size is x, you can do x minus one swaps to basically make them right. So this is the learning that I'm going to take forward with me, so that if I encounter such scenario, I have an intuition of how to approach such problems. So this is the key takeaway for me from this, as well as another key takeaway for me is I need to do more practice. As you can see, like I was missing few of the edge cases. For example, in the first question, which was easy, I still made a mistake. So I need to do more practice. It might take me some time, probably 3 or 4 days, but I'm sure that doing this consistently will train your mind. So definitely, if you are going for interviews, I would really suggest you to do what we did today. I hope to do more such live streams. Let me know in comment if you want to do such things more often, so that you can also see once you are stuck how to make progress. For example, doing see out statements, going through your code once, right? Such things really help. I hope that if you are stuck, you can also see how to handle such situations and make progress. For example, like this listed was missing and all those things. We do make silly mistakes, and it's part of our job to debug things out. So I hope you also learned something from this. Let me know in comments, and I'll simply now switch to comments and answer if you have any questions. And with that, we'll end the session after some time. Like this is time for Q&A now. All right. Thanks, guys. Do we have any questions? All right, people are saying that it's good and we should do it more often. All right. Any questions do you have from today's question? Any question you had, any doubt or any suggestions, anything? Aditya Tomar is asking, do I give CB contest by the performance that I gave today? I'm not doing CP contest now. I'm really much more fascinated by development in general, and I have been, basically I was really strong with C++, but then I spent a lot of time doing doing Python and JavaScript. Then JavaScript has a lot of things, Node.js, Express, React hooks. So I have been doing more of those things as well. So I couldn't find time to do competitive programming. I'm doing this session today just to, relive that kind of thing and gain that expertise back, because competitive programming, as I've said so many times, it keeps your mind sharp, and I do need that at this stage. All right, some people are saying that I have taught them more than their college. So yeah, thanks for such kind words. I'm really happy to hear that. Okay, someone is suggesting to do more problems on DP, tries, and segment trees. Sure, we will do that. We will definitely do that. And it's actually good for me also to do such things, because this is kind of, um, it's giving me pressure, like doing this live on like YouTube. So many people are watching. You have to approach problem from scratch, and you have to make progress at the same time, communicate with so many people, and writing code at the same time. So it kind of puts you in a real pressure scenario. That's what I'm saying. You might be uncomfortable sometimes dealing with that pressure, but yeah, you have to deal with that. So that's something which I feel that I'm doing a good job, but I will improve doing such sessions. So yeah, it's good for me also. All right. What is my code forces ID? It's Rachit IITR on all handles. So basically, you can follow me everywhere using Rachit IITR. That's my handle. I also have a meme channel on Instagram, which is I can't name variables. But yeah, coming back. All right. Any more questions? How often are we planning on doing this? We will be doing this basically more on weekends and sometimes on weekdays as well. I started feeling that I should do more of live streams, because I because I am good at problem solving and data structures and algorithms, and I hope that with once I'm in practice, I'll be able to do more justice and add more meaning to your lives in a given time frame. I hope I really apologize if it took me so long time to solve three problems, but I was, as I'm saying, like no revision, nothing. Like I learned all these things lot of long time back, and so yeah, I'll be more prepared once I do these things quite often, and I'll be more useful in and I can also impress you guys more uh, like in the coming few days. So yeah, I plan to do this consistently for a few weeks, so you can see more such live streams. All right, anything else? Someone is asking to give code. So, okay, I'll be pushing everything to GitHub. I already have this repo, GitHub Rachit IITR. So I have this. I do have other repos as well. Like if this is code forces contest bot. I also have a video which talks about how to use this bot. Um, so I upload all my lead code solutions to data structures algorithms repo. It's also having everything, like all my templates. It's having that for segment trees, for graphs, everything. In the lead code folder, you can expect to have these three solutions, but in like in the next 10 minutes, I'll be uploading all the solutions here. Okay, so I'll also be doing one thing. I'll be updating the video description with the problems that we have solved today. And I'll see you like maybe tomorrow or late at night if you guys want a session at probably 11 p.m. or 12 a.m. I can do that as well. So my lead code username is Rachit IITR. I have actually renamed that to something else right now, but I'm using a fresh lead code account just so that because I was also going live. I wanted no history. Like if I was using my old account, I could have seen that I have solved these problems already. I wanted to give a fresh start. So yeah. All right. I'll be sharing the new lead code ID that I have. It's Rachit IITR underscore online. You can check that out if you want to see the solutions. I think you can see the solutions from here as well. Like you can have the submissions list over here, right? So as I'm saying, I hadn't solved these problems before. This was a new account, and going forward also, like I'll be doing this live, making mistakes like we did. But yeah, I'm really happy that this problem, once we were able to make progress, we solved it without making any mistakes. So that's really good. We were able to handle test cases as well. All right, guys. Thanks everyone for joining me today. I hope you had fun. I did not expect, to be honest, I did not expect that this will take so long, but yeah, it did. Unfortunately, I'm out of practice. That's how I would look at it. And I am out of practice means that I have to work more hard. That's it. And that's what I'll be doing. I'm definitely sure that within few days you will be seeing, I'm sure that, I'll be able to grasp problems much faster, and I'll be able to write even um, cleaner solutions, like the test cases and corner cases. I'll be, like my mind will be more trained to handle all that. All right. This was really bad idea to, to resume your problem solving and data structure kind of things with such advanced topics. But yeah, this was really fun. I really enjoyed this live stream. I'm not going to delete it. This was really fun for me as well. I had a great time. I'll see you in the next one. Let's end the live stream now, guys. I'll see you in the next one. All right, bye. All right, guys, bye. Again, you can follow me on social media. The links are over here. That and with that, I will take your leave. Happy coding. Take care. Stay safe, and bye bye.